We have learned to compute averages and standard deviations, but now we will use the same information or same knowledge to make comparisons between groups. So we will use the same data set that we have used so far, that is the teaching evaluation data from University of Texas, comprising 463 courses. We are looking at the teaching evaluation, beauty, and age, and we're comparing the averages for these three variables for female instructor variable. So those who are females, their average teaching evaluation was 3.9 compared to those of men, 4.06. Here we are looking at the average teaching evaluation for tenured professors, 3.96 versus untenured, 4.13. The average age of untenured professors was 50.2 years, and that for tenured professors, 47.85 years. One thing that is very important in statistical analysis is to think about the question and to think about the population or sample that you are working with. We are computing averages across 463 courses, and we find the average age or beauty, but these are the attributes of instructors. We know from our data that there are 94 instructors who have collectively taught 463 courses. And we know that there are duplicates, that is the same instructor who has taught multiple courses. So when I compute the average age using 463 courses, it's not necessarily the average age of the instructors, because it could be true that older aged individuals may have taught more courses than younger individuals, resulting in a higher average. That is not necessarily the average age of the instructors. So to avoid this problem, we have to subset the data so that we remove the duplicates and have only one observation per individual instructor in the data set. So instead of 463 observations, we should have just 94 observations. So SPSS has these abilities to identify duplicates and remove them, or at least allow us to create a new variable based on which we can filter the data. Therefore, I have used the identify duplicate cases algorithm in SPSS to subset the data set. The algorithm generates this script. You can actually highlight this script and run it to get the same effect. Now let's look at the comparison. When we use 94 observations where no instructor is repeated in the dataset, the average age or average beauty score is 0.25. When we look at the 463 courses, the average value is 0.11. Or let's compare the age. The average age using 94 observations for males is 49.4 and for females is 44.9. And you see here that as for age, we don't see much difference whether we use 463 observations or 94, but we certainly see much difference in the beauty scores if we were to use the wrong data set, that is the data set where individuals are repeated multiple times. So with the same data set, we click on Analyze, Reports, Case Summaries, and this dialog box would come up, and then we select the variables of interest, which are the continuous variables. So we pick the age of the instructor, the beauty score, and the teaching evaluation score, and then we can select the grouping variables, let's say female instructor, and we got this here. We deselect this duplicate cases checkbox and click on statistics to identify the statistics. So we want to have the mean and the standard deviation. Here it is, and so continue, and then I click OK, and I have the results presented here. I got the mean, the standard deviation for female and male instructors separately, and the case summaries dialog box generates this. To identify duplicates, I click on Data, Identify Duplicate Cases, and it will open up a new dialog box and define matching cases by, and there's a variable that identifies each professor. So we click that and then say OK, and then it will create a new variable through which we can filter the data set. SPSS will automatically generate this variable called primary last, and it will identify each instructor by 1 and 0 for its repeat observations. We will filter the data set, so we say Data, select Cases, and say if condition is satisfied, click on if, and then say indicator variable is equal to 1, and it will only select those variables that are those cases that have the variable assuming 1. So continue and say OK. Once we have run the filtered command, it will identify all the filtered out cases by a diagonal line through those. So rows 1, 2, and 3 are filtered out, but rows 4 are there. And we can repeat our analysis by saying summarize cases. It's populated the same way, but this time around it will run only on 94 observations. So we click OK, and we have the data set with 94 observations in total. And you could see that the beauty score now is different. Mean is minus 0.0331 for males and 0.2523 for females. Click on data, select cases, and say select all cases. You will notice that the filtered out observations have re-entered the data set. We can also compute the same type of statistics such as mean and standard deviation, but then we can look at it from a multi-dimensional view. For example, what is the average age of a female professor who's tenured and speaks English as a native speaker? We can do this using SPSS. Let me show you how. First, we select cases. If condition is satisfied, our condition is already specified there. We say OK, and we see that these cases are filtered out. And then we say analyze, reports, case summaries. And then here we have the 3 variables of interest as grouping variables. Age of the instructor is the variable of interest, and we click OK, and we have the same output as we have seen earlier.